This is a video on the unit tangent and unit normal vectors. The question states, find the unit tangent vector t of t, the unit normal vector n of t, the tangential component of the acceleration a sub t, and the normal component of the acceleration a sub n at t equals pi over 3 for the vector valued function r of t is equal to 2ti plus cosine of tj minus sine of tk. So let's first find the velocity and then the acceleration vectors. The velocity vector is a derivative of r of t, and that is just 2i minus sine of tj minus cosine of tk. And then I plug in pi over 3, and I get that the velocity vector at pi over 3 is 2i minus root 3 over 2j minus 1/2 k. So to find the acceleration vector, I take the derivative of the velocity vector, and that is just negative the cosine of tj plus the sine of tk. And if I plug in pi over 3, I get negative 1/2 j plus root 3 over 2k. So I now have my velocity and acceleration vectors. Let's work on the information that's requested. First, the unit tangent vector. The unit tangent vector is defined by the velocity vector over the magnitude of the velocity vector. So I compute 2i minus root 3 over 2j minus 1/2 k divided by its magnitude. I take 2 squared or 4, root 3 over 2 quantity squared is 3/4, and 1/2 squared is 1/4, and I add those up. Notice 3 over 4 plus 1 over 4 is just 1, so this just gives me root 5. So I can write the unit tangent vector as 2 over root 5i minus root 3 over 2 root 5j, and then minus 1 over 2 root 5k. So there's my unit tangent vector at pi over 3. For now, I'm going to skip the unit normal vector and move right to the tangential component of the acceleration. So to do that, I use a formula that says that a sub t is v dot a over the magnitude of v. So let's find the dot product. That's going to be 2 times 0 minus negative root 3 over 2 times negative 1/2, and then plus negative 1/2 times root 3 over 2. And the magnitude of v, remember, was root 5. But anyhow, I get root 3 over 4 minus root 3 over 4 on the top, so this fraction is just 0. So the tangential component of the acceleration vector at pi over 3 is equal to 0. So now let's find the normal component of the acceleration vector a sub n. And I use a formula that says that a sub n is equal to the square root of the magnitude of a squared minus a sub t squared. A sub t is just 0, so this is just the magnitude of a quantity squared with the square root, and that's just the magnitude of a. But the magnitude of a, that's just the square of negative 1/2, that's 1/4, and then plus the square of root 3 over 2, that's 3/4, and then all under a square root. So 1/4 plus 3/4 is 1, and the square root of 1 is 1. So I just get that the normal component of the acceleration vector is equal to 1. So I'm going to use these to find the unit normal vector. I have the formula that the acceleration vector is equal to a sub t times t plus a sub n times n. But a sub t is just 0, so that part drops out, and a sub n is 1. So the acceleration vector is equal to the normal vector. So the normal vector at pi over 3 is equal to the acceleration vector at pi over 3, and that, recall, was negative 1/2 j plus root 3 over 2k. And I'm done with the problem.